Sure somebody has. Okay, so we're going to do quite a bit of notes today and examples on the different types of concentrations you look at with solutions. And then tomorrow, it'll just be a whole day of you being able to do practice. So that means I expect you to do some practice at home so you can come with your questions. And then we'll quiz over that beginning Friday. So we're going to get our notes out of the way today in one lump sum and not have to worry about that. All right. All right. Hopefully everybody got this answered. It was straight out of your notes. And we dealt a little bit with it yesterday. All right. All right. So we are right here. And we're going to be looking at a couple of formulas today. They're pretty similar. And, all right. So the first one is the most common one. And it's called molarity. And both of the formulas we'll do today are looking at at different ways to look at the concentrations of a solution. The number of moles of solute per liter of solution. And it's designated by a big M. It has to be a big M because in a minute we'll do one with a little m. So moles of solute per liter of solution. And just like with the ideal gas law, we'll come with some of those same issues, not being given moles directly, being given grams and having to use a molar mass to get to moles, and then given the solution in milliliters and having to convert to liters. Remember, if I have 333 mLs and I need to convert that to liters, just like we did between grams and kilograms. No, we did liters and milliliters before. Move your place back 3 places. So that would become 0.333 liters. Because they'll throw that at you sometimes. All right, so let's just kind of look at some different problems and some different ways that we may see this formula. Because it usually isn't just straightforward. That would be too easy and too uneventful. Calculate the molarity of a solution prepared by dissolving 11.85 grams of potassium per manganate. If you notice, I put your ion sheet there because you're going to be figuring molar masses. You're going to have to be writing some formulas too. In enough water to make 750 mils of solution. So right away, I'm going to go ahead and change that to 0.750 liters because I know I need it in liters. No, the ion sheet, you have a periodic table on one. And I had 3 sig figs to begin with when it was milliliters, so I had to have 3 sig figs when it became liters. So I'm just going to jot my formula over here. Moles of solute, liters of solution. So I have the liters of solution. I don't have moles of solute. I have grams of solute. I can't put that in there. So we have to use the molar mass like we do a lot and get it to moles. So I have 11.85 grams of potassium permanganate. I need to convert that to moles, and 1 mole has a molar mass of 158.04 grams. Well, remember, when you're going from grams to moles, your number's going to get smaller. You're dividing, and then there'll probably be some point where you have to go from moles to grams, and your number should get larger. All right, so at this point, we have 3 sig figs because of our 11.85. So we would get 0.7498 moles. So now I have my numerator. So I take my number of moles and I divide it by my liters, 0.750 liters. Now we're down to 3 sig figs. So top number divided by my bottom number. I think you get a bunch of 9. So when you round correctly, it becomes 0.100 molar, big M. And you would have to include those zeros because you needed the sig figs. So sometimes I have, don't write this down because you don't need to. Sometimes I have students turning in their answers like this. That is not the correct way to use your units. That would not be counted correct. You've got to have the M behind the number, okay? And sometimes I have people ask me about it, but sometimes I just continue to do that. But for it to be correctly, your units have to be behind the number. All right, does anybody have any questions in that first one? All right, not too bad. Let's look at a couple of other ones where you're going to have to do a little bit more algebra. This one says calculate the mass of sodium chloride. So I'm trying to find grams of sodium chloride. Needed to prepare 175 mils of a 0.5 molar solution. So I'm going to change my 175 mils to 0.175 liters. So on this one, I already have the molarity. I'm not trying to calculate it. So my formula, I already have the molarity. I have the liters of solution, which was my 0.175 liters. And what I'm trying to find is how many moles of sodium chloride I have. Because then if I find out how many moles I have, I can use the molar mass to get it to grams. So this is your little bit of algebra, one of your little bits of algebra. This is in the denominator. When I bring it up here to the numerator, that just means I am multiplying those two numbers together, right? 0.50 times 0.175 would be equal to my X. So in this case, my X is some numbers. 0.0875, and that's moles because that's what is on what we were trying to find. So you don't have to write this step every time because you're going to be doing that same thing. You're always going to be, when you move that denominator to the other side, it's just going to be multiplying it. So that's how many moles I have, but of course we want it in grams. So 0.0875 moles. I want it in grams. So we're going to have to do the molar mass. 1 mole is 58.44 grams. So now we just multiply 3 sig figs. So we would get 5.11 grams. So notice, like I said earlier, if I'm going grams to moles, my number is going to get smaller. But if I'm going moles and trying to convert it to grams, your number should get bigger because you're doing a multiplication. Anybody have any questions on any of that or that little bit of algebra or anything?
The 58.44 is the molar mass?
Yeah, like if you would have had to look up on the periodic table. Yeah. Yep. All right, then let's look at one more exciting example. Calculate the volume in mils needed to prepare a 2.48 molar sodium hydroxide solution containing 31.85 grams of the dissolved solid. So our dissolved solid is our sodium hydroxide. So I already have the molarity. Calculate the volume. So that means that's the unknown. So now my X is on my denominator. At the top, I need moles of sodium hydroxide, but of course I don't have it. I have grams, so we're going to have to use a molar mass again. So you're using a lot of molar mass in this. So I have 31.52 grams. I need to get it to moles. So 1 mole has a mass of 40 grams. So my top number divided by 40. 7,880 moles. That's hopefully what y'all got. At this point, we're at 4 sig figs. We'll eventually get down to 3 sig figs because of that. So this comes up here. All right, so I'm trying to find X. So this one is a little bit more algebra. If I bring my X up here, it becomes 2.48. X is equal to 0.7880, right? Divide each side by 2.48. So that cancels. This is what I'm interested in. So when you do that, you get 0.318 liters. And my question was calculate the volume in milliliters. So what do I need to do to make that become milliliters? 3 places other way, right? So all that'll become your final answer. Any questions on any of those? Nope. We went a few days without having to use a calculator, I feel like. All right. Now let's look at, if you're one of my regular students, this is where we stopped on, what is it? Wednesday? Say Wednesday? Yeah, this is where we stopped on Wednesday. For my honors, we moved on. I'm recording, so I don't want to have to. I'm recording, so I don't want to have to record twice. So. Anyway, all right. So now talking about molarity of ions in solution and how you find their concentration. Whenever an ionic compound, which we remember is a metal plus a nonmetal, or it could be a metal plus a polyatomic ion, whenever they're put in water, which is what we're talking about now, if something is a solution, we're putting it in water. That's your AQ, then it's going to ionize. And if I know the strength of the beginning solution, I can know the strength of the ions. So let's just take our calcium chloride. It's going to ionize into calcium ions and chloride ions. Calcium doesn't have a subscript, so that means I just have one calcium ion, and it's a +2. You have to look that up on your ion sheet if you don't remember. And then my chloride, I have a subscript of 2, so that means I have 2 of my chloride ions. If you've ionized them correctly, it should be neutral, and it is. I have a +2 here, 2 times -1, I have a -2. So let's say that I said this is a 0.3 molar solution. To get the strength of the ions, you simply take that original strength and multiply it by the coefficients. So for my calcium, for my cation, it would still be 0.3 molar because there's only one of those. But for my chloride, I would do 2 times 0.3, and it would give me a 0.6 molar. So I know that some of y'all really avoid writing formulas, but you're going to have a little bit of formulas in this unit. And also remember, your positive ion is your cation, your negative ion is your anion. Because in your practice and on the quiz, I'm telling you there's one of these on the quiz, I ask you what's the concentration of the cation, what's the concentration of the anion. Okay? So let's look at one more, and then y'all can give one a try. Calcium is a +2. Phosphide's a -3. So if I write that formula, it is Ca3P2. All right, so when it ionizes, I have 3 of my calcium ions, subscript of 3, and 2 of my phosphide, and they're -3. So once again, if you notice, 3 times 2 is +3, 2 times -3, -6. I said that wrong. 3 times 2 is +6. It says it's 0.25 molar. So 3 times 0.25 would be 0.75 molar. And then 2 times 0.25 would be 0.50 molar. So just take your coefficient and multiply it. Notice originally it was 2 sig figs. I had to make sure that these were 2 sig figs. Like I couldn't have just said 0.5 hit there. All right, why don't y'all try that next one, and I'll tell you what their charges are in case you hadn't gotten out your ion sheet yet. Silver is a +1, and sulfite, which sulfite is SO3, it's a -2. So that should help you write the formula, and then go ahead and go through and see if you can ionize it. Louis, sit up and try it. Give it a try. So this should have been your formula to begin with. Ag2SO3. So when it ionizes, I'll have 2 silver and 1 sulfite. So this is 0.33 molar. So what would my silver be? 0.6, perfect. And my sulfite would be 0.33, perfect. All right. I'm sorry, say that again. I didn't hear. Molarity. Yes, that's your concentration. We're going to do another concentration called molality here now. I didn't name them. But molarity, big M, that's like the really common one. Yeah.
And then, does the charges on the side of the equation affect
The molarity, the concentration? No, just the coefficient. Just the coefficient. All right, so we're going to go ahead and do our other concentration today. The problems are real similar to these. I mean, to the ones we just did. So we'll move through those. And like I said, get our notes out of the way for today. So molality, I didn't name them, that they had to be so similar, is the number of moles of solute. So that's the same, but now we have kilograms of solvent. And it's represented by a lowercase m, little m. So moles of solute per kilograms of solvent. Sometimes that kilograms of just the solvent makes it a little bit harder. but a lot of times it doesn't. I think there's a few harder problems in your practice, and I'm going to look at those tonight and maybe look at a couple of those tomorrow together when we do our practice. Uh, excuse me. So you can see we're going to have the same problem. Things being given in grams, we have to convert to moles. Also, remember, if you're given something in grams, it's the same thing. If I have 100 grams, 1, 2, 3, move my decimal place back 3, and that's the same number of kilograms. So it's just like the liter to milliliter. All right, so it says calculate the molality of the solution prepared by dissolving 15.4 grams of potassium hydroxide in enough water to make 750 grams of water. So we're using 750 grams of water. That's our solvent. So right away, I'm going to move my decimal back 3 and make that 0.750 kilograms. And once again, it was 3 sig figs to begin with, so I want to be sure that I carry that 0. So just like with our other formula, we don't have moles of solid, we have grams, so I'm going to have to use my molar mass. Grams of potassium hydroxide. And 1 mole has a molar mass of 56.11 grams. So we end up with 0.2770 moles. So that's my moles, and I need to divide that by kilograms of solvent, which is my 0.750 kilograms. Now, because we're using the 0.750, that's 3 sig figs, so my answer should have 3 sig figs. 0.369, and this one is a little m instead of a big M. So similar types of problems. Similar types of problems. Anybody have any questions on that one? That's my molar mass that I calculated off the periodic table, if you're wondering where that came from. All righty. We're going to look at a couple more. We've already kind of looked at one like the next one. I'm already have the little m, already have my molality, so that means I'm trying to figure out something else. So how many grams of calcium chloride must be dissolved, so that's my solute, in water to make 350 grams of a 1.75 molar solution. So that 350 is how many grams of solvent I have, because the calcium chloride is a solid, so it's not going to be any part of that solvent. So I would make that 0.35 kilograms. No, ma'am, because the 0 is not significant in the original 350 because there's no decimal behind it. So then I don't want to carry it with me. All right, so to get to grams of calcium chloride, I need to know moles. So we got to do that, figure out our moles. So 1.75 little m is equal to x over 0.35 kilograms. So to get my x, all I'm going to do is take that up, and when I do, I'm multiplying. So I'm going to multiply 1.75 times 0.35. And somewhere I have an answer for that. 0.61, right? 0.61, and that is moles. But of course, we wouldn't want to just leave it at that. We want in grams, so I'm going to now have to do that. So I'd have to figure the molar mass of calcium chloride, 2 chlorides and 1 calcium would give me 110.5 0.98 grams per 1 mole. Remember, I need my units to cancel out, so that's why this is a multiplication problem. So after that and all that, we end up with just needing 2 sig figs. So did you get 68 grams? All right. All right, and then the last one, it's really not anything real different, but it uses something that we kind of use in this unit. It says, what is the molality? So I'm looking for the little m of a solution that has 43.7 grams of sodium nitrate, which is NaNO3. So I know that I'm going to have to use a molar mass and get moles. And it's dissolved in 750 mils of water. So it seems like there's a problem because for molality, I don't need mils of water. I need kilograms of water. But the density of water is 1 gram per 1 ml. So that means if I have 750 mLs, I also have 750 grams. So that density of water comes in handy because if you know how many mils you have, you know how many grams you have. And then we would move our decimal 3 places, 0.750 kilograms. For what we're, yes, usually it does. I think there's some harder problems on the practice I'm gonna look over tonight that you have to do a little bit more work. Because like if you have a these are all where we have solid solutes, but if you have a liquid solute, which you can, then when you get the total amount of solution, you have to subtract that out to get just to the solute. But like I said, don't worry about those tonight. They're toward the end of the practice, and I'll talk about some of those tomorrow. So now once we've done this is just what was important to know, and we probably haven't talked about that yet. Now you're just ready to finish it out. So I would take my 43.7 grams and I would divide that by the molar mass, which is 85 grams per 1 mole. So 0.514 moles divided by my kilograms I got right there, 0.750 kilograms. And I'd get me a little answer. 0.685 little m. Is that what you got? So just remember that density of water. There's some in your, but I'll talk about those tomorrow. All right, so that's a good place. You got about 10 minutes to work on some of the practice. If you have any questions, let me know. That's why I get paid the big bucks. Please do some practice at home so you can come back with good questions tomorrow in case you're stuck. Take care of all those before the quiz.